At this time, we are going through the details related to performance tuning of SQL queries. We have understood how to generate explain plans. We have spent some time in interpreting some of the key aspects within the explain plan. We have even created a scenario to see whether there are any performance bottlenecks or not. After identifying the query, which actually return the details about orders placed by the customer, when we try to run same query 1000 times, we have observed that it was taking 18 seconds. For 2000 times, it was taking 35 seconds. Now it is time for us to take care of addressing the bottleneck by creating required indexes. The original query is nothing but this one. It will give us the number of items that are bought by the customer over a period of time. For customer ID 5, the number of items he bought is nothing but 7. You should be able to click on this to get the explain plan. The two bottlenecks which I have identified earlier are nothing but full table scan on orders. Sequence scan means full table scan in Postgres. Also full table scan on odd items. On top of these two, even the hash join is a bottleneck. In this case, the hash join is performed on 5 records from orders and unfiltered 172,198 records on odd items. However, this is a side effect of not having appropriate indexes on orders and odd items. First, let's go ahead and create index on order customer ID. As part of the data model, when it comes to orders, it is child table to customers. Even though it is child table to customers, there is no foreign key constraint defined. You can actually review the details here. As part of the orders, we have only one constraint, which is nothing but orders underscore p key. There is no foreign key constraint between orders order customer ID and customers customer ID. Let's go ahead and first add the foreign key constraint. In this case, you should be able to use alter table command to take care of adding the foreign key constraint. I should be able to say alter table orders here, then add foreign key. We have to add foreign key on order customer ID. It should be referencing customers customer underscore ID. Customer underscore ID is the primary key in customers table. Now let's select this and run this. Now alter table on orders is run successfully. Let's refresh orders here. If you look at the constraints, we have this new constraint. Let's review the explain plan for this query. It is still the same. Whatever we have seen earlier, the same is seen here. It means when we add foreign key, it will not add the index on this foreign key column. On order customer ID, there is no index. We need to make sure we add the index. Before getting into the details with respect to adding the index, let's run this once again. Here we are trying to invoke the same query 2000 times. Let's see how long it will take after adding the foreign key constraint. Now the stored procedure is executed successfully. You can see that it have taken close to 34 seconds. Earlier it was a bit more than 35 seconds. This time it is a bit under 34 seconds. More or less the execution time is same. Now let's go ahead and add index on order customer ID of orders. For that I should be able to use this statement. Create index orders order underscore customer underscore ID underscore IDX on orders order underscore customer underscore ID. Now let me select this create index statement and run it. You can see that it is executed successfully. Now let's go up here. Let's review the explain plan after creating the index. This time it is different. When it comes to orders on order customer ID equal to 5, it is performing something called as bitmap index scan. The key is it is using index scan. It is not using a sequence scan or full table scan. It is using index scan. However, when it comes to order items, it is still saying sequence scan, which is nothing but full table scan. It is because we haven't created index on order items. We'll take care of it very soon. However, let's run this piece of code to see how long it will take to run this query 2000 times with 2000 different customer IDs. Let's select this. Let's click on execute or refresh here. Let's see how long it's gonna take this time. This time it have taken 20 seconds. From 36 seconds, it came down to 20 seconds. You are almost seeing 50% improvement in the performance. Now let's add one more index. This time the index is supposed to be added on order item order ID of order items. If you review the details with respect to order items, as of now we have two constraints. One is nothing but order items p key. The second one is nothing but order items order item order ID foreign key. This is referring to orders order ID. Foreign keys doesn't guarantee indexes. We have to create indexes explicitly. Let's go ahead and define index on this field. Let's see whether it will improve the performance further or not. Let me go here. Let me say create index. The index name is nothing but order underscore items, then order underscore item underscore order underscore ID underscore IDX, then on order underscore items, order item, order ID. Now let's select this and click on execute or refresh. Now the index is created. Let's review the explain plan for this. If you observe the explain plan, this time it is actually doing index scan on orders, order customer ID, also index scan on order items, order item, order ID. When it comes to the inner join, this time it is performing nested loop inner join. It is not performing the hash inner join. Also, when it comes to order items, instead of scanning the entire 172,198 records, it is only scanning few records via index. You can go to the details here. I will spend more time on this at a later point in time. For now, on both orders and order items, the required indexes are there. Because of that, it is actually performing index related scans, and also when it comes to joining the data between orders and order items, it is performing nested loop inner join, not hash inner join. That being said, now let's scroll down. Let's select this and then click on this to see how long it will take this time. It have come down to 211 milliseconds. From 35 seconds, it have come down to 211 milliseconds just because we have added 2 indexes on 2 tables. The performance improvement is hundreds of times, not just 50% or 10% or 30%. This is how you should be able to tune the performance by adding relevant indexes on relevant fields. We'll actually spend a little bit of time in interpreting the explain plan as part of the next lecture. As part of this lecture, we have gone to the details about creating required indexes, and we have experienced whether there is performance improvement or not. There is significant amount of performance improvement. From 35 seconds, by adding just one index, we have brought it down to 20 seconds. From 20 seconds, by adding another index, we have brought it down to 211 milliseconds.